Hello everyone, this is Shaka. You are watching my YouTube channel. In the previous videos, we learned about remote sensing, its definition, scope, applications, types of digital images, and much more. Now, we will learn about types of remote sensing system. There are different types of remote sensing system. Without any late, let's start the video. Number 1. Visual Remote Sensing System. The human visual system is an example of a remote sensing system in the general sense. The sensors in this example are the two types of photosensitive cells known as the cones and the rods at the retina of the eyes. The cones are responsible for color vision. There are three types of cones, each being sensitive to one of the red, green, and blue regions of the visible spectrum. Thus, it is not coincidental that the modern computer display monitors make use of the same three primary colors to generate a multitude of colors for displaying color images. The cones are insensitive under low light illumination condition when their jobs are taken over by the rods. The rods are sensitive only to the total light intensity. Hence, everything appears in shades of gray when there is insufficient light, as the objects or events being observed are located far away from the eyes. The information needs a carrier to travel from the objects to the eyes. In this case, the information carrier is the visible light, a part of the electromagnetic spectrum. The objects reflects or scatter the ambient light falling onto them. Part of the scattered light is intercepted by the eyes, forming an image on the retina after passing through the optical system of the eyes. The signals generated at the retina are carried via the nerve fibers to the brain, the central processing unit, that is CPU of the visual system. These signals are processed and interpreted at the brain with the aid of previous experiences. The visual system is an example of a passive remote sensing system which depend upon an external source of energy to operate. We all know that this system won't work in darkness. Next one is optical remote sensing. In optical remote sensing, optical sensors detect solar radiation reflected or scattered from the earth, forming images resembling photographs taken by a camera high up in space. The wavelength region usually extends from the visible and near infrared VNIR to the shortwave infrared SWIR. Different materials such as water, soil, vegetations, buildings, and roads reflect a visible and infrared light in different ways. They have different colors and brightness when seen under the sun. The interpretations of optical images require the knowledge of the spectral reflectance signatures of the various materials, that is, natural or man made, covering the surface of the earth. Next one is infrared remote sensing. Infrared remote sensing makes use of infrared sensors to detect infrared radiation emitted from the Earth's surface. The middle wave infrared, that is MWIR, and long wave infrared, that is LWIR, are within the thermal infrared regions. These radiations are emitted from warm objects such as the Earth's surface. They are used in satellite remote sensing for measurements of the Earth's land and sea surface temperature. Thermal infrared remote sensing is also often used for detection of forest fires, volcanoes, oil fires. Next one is the diagram that you can see. In this diagram, as you can see, sun is the source of energy, and from that it is the energy that is derived and scattered on forest, water, grass, bare soil, paved road, and built up area, and much more. From these, the energy is reflected back to the satellite, and that is how remote sensing works. And through this, how the image get received from the satellite through various sensors. And next one is microwave remote sensing. Next one is microwave remote sensing. There are some remote sensing satellites which carry passive or active microwave sensors. The active sensors emit pulses of microwave radiation to illuminate the areas to be imaged. Images of the Earth's surface are formed by measuring the microwave energy scattered by the ground or sea back to the sensors. These satellites carry their own flashlight emitting microwaves to illuminate their targets. The images can thus be acquired day and night. Microwaves have an additional advantage as they can penetrate clouds. Images can be acquired even when there are clouds covering the Earth's surface. A microwave imaging system which can produce high resolution image of the Earth is the synthetic aperture radar, that is SAR. Electromagnetic radiation in the microwave wavelength region is used in remote sensing to provide useful information about the Earth's atmosphere, land, and ocean. When microwaves strike a surface, the proportion of energy scattered back to the sensor depends on many factors. These are physical factors such as the dielectric constant of the surface materials, which also depends strongly on the moisture content. Second, geometric factors such as surface roughness, slopes, orientation of the objects relative to the radar, beam direction. Third, the types of land cover, that is soil, vegetation, or man-made objects. Fourth, microwave frequency, polarization, and incident angle. Next one is radar remote sensing. Using radar, geographers can effectively map out the terrain of a territory. Radar works by sending out radio signals and then waiting for them to bounce off the ground and return. By measuring the amount of time it takes for the signals to return, it is possible to create a very accurate topographic map. An important advantage to use radar is that it can penetrate thick clouds and moisture. This allows scientists to accurately map areas such as rainforest, which are otherwise too obscured by clouds and rain. Imaging radar systems are versatile sources of remotely sensed images, providing day-night all-weather imaging capability. Radar images are used to map landforms and geologic structure, soil types, vegetation and crops, and ice and oil slicks on the ocean surface. Next one is synthetic aperture radar, that is SAR. SAR. In synthetic aperture radar imaging, microwaves pulses are transmitted by an antenna towards the Earth's surface. The microwave energy scattered back to the spacecraft is measured. The SAR makes use of the radar principle to form an image by utilizing the time delay of the backscattered signals. In real aperture radar imaging, the ground resolution is limited by the size of the microwave beam sent out from the antenna. This is a diagrammatic representation of synthetic aperture radar. In this diagram, as you can see that the microwave pulses are transmitted by the antenna to the Earth's surface, and the ground target. The microwave energy scattered back to the spacecraft is measured. And next one is satellite remote sensing. In this you will see many remote sensing images acquired by Earth observation satellite. These remote sensing satellites are equipped with sensors looking down to the Earth. They are the eyes in the sky, constantly observing the Earth as they go round in predictable orbits. Orbital platforms collect and transmit data from different parts of the electromagnetic spectrum, which in conjunction with larger scale aerial or ground based sensing and analysis provides researchers with enough information to monitor trends. Other uses include different areas of the earth sciences such as natural resource management, agricultural fields such as land usage and conservation, and national security and overhead ground based and standoff collection on border areas. If you really like this video, then please like and subscribe to my channel. If you want to latest updates and more videos on remote sensing, environmental science and GIS, then please hit the bell icon to get the latest notifications and updates of the videos on such educational one. Thank you so much. Follow for more.